Alright, so this is question 5 from the practice exam. This is probably going to take like maybe 2 videos to go through it all. So the question is, what is the major product for the following reactions? For the following reaction. Alright, so they give us this cyclopentane molecule. I think, what is that, an allyl group or a vinyl group? I gotta look that up. Okay. And then, so what they're saying is that first they treat it with HGOAC2 and H2O, and then they treat it with NaBH4 with NaOH, right? Alright, so I had to do some background info on this. Alright, so I got this from the slide. Alcohols from alkenes through oxymercuration demercuration. Alright, and it follows Markovnikov addition. Right? So whenever you see something like this, when you have a reaction, you see something of the variety like mercury with, I think that's acetic acid, but I'm not sure, HGOAC and THF and H2O, and then treated next with NaBH4OH minus, you know that you're doing an oxymercuration demercuration. You see mercury on the first one and H2O, and then you see NaBH4 and OH minus in the second, you know that this is what you're doing. So that's how we know this is what we're going to be doing with this reaction. Alright, so an important thing with this, it's supposed to be star, proceeds with high yields of alcohols, and most importantly avoids rearrangements. So you're not going to get rearrangements, you're not going to get you're going to have no methanide shifts, methanide or hydride shifts. So let's do the mechanism for this. Now I'm just going to do part of the mechanism. There's a more intense version of the mechanism, but I don't have time for that right now, and it's not necessarily, well, I'll do it eventually, but just not today. Alright, so the mechanism for this oxymercuration, demercuration. Step 1 is oxymercuration. Okay, so we have an alkene. And then we treat it with H2O and the mercury. This is that. This is the OAC. Alright, and we treat it in THF. So that's the first step. With the mercury, the water, THF. So what do we get? We get COH. How you get that O right there is the more intense mechanism, which I'm not going to go over right now. Oh no, I'm sorry. There's two here, not that's two. All right. So the alcohol right here came from the water, the HO, and then the other H went here to this molecule. I mean, not the most 100% important at the moment, but eventually we'll figure that out why that happens. So what we should know is that the Hg molecule okay, I'm not going to get into that right now. So when you have an alkene, and you treat it with this reagent or with this mechanism, an OH molecule is going to go onto one of the carbons, and then you're going to get this Hg dash. You're going to get this Hg complex on the other one, and then you have step 2, which is demercuration. And in step 2, demercuration, so we have the molecule, right? We have the mercury complex, and we're going to add hydroxyl ion and NaBH4, and without elucidating the complexity of that mechanism, what we need to know for right now is that it forms OH, that wherever the mercury was, it gets replaced with an H. That's all we need to know. It gets replaced with the H. The mercury breaks off, and so it's two components. Right, so that's what we get. So basically, we have the alkene, we treat it with the mercury, H2O, and THF. We get an OH on one, the mercury complex on another. Step 2 is demercuration. We add hydroxyl and NaBH4, and we get the water remains where it was, and where the mercury complex was, we get NH. I hate just being like, just accept the mechanism without understanding it, but I don't think I have time. Okay, ready, 50. Okay, so another thing we want to know really quickly is that the mechanism shows Markovnikov selectivity. So we have step 1. Markovnikov selectivity is, okay, we've gone over that. Oxymercuration. So that's step 1, is oxymercuration. So here we have this molecule CH3, which is connected to CH2, which connects to CH, double bonded to a CH2. And we treat it with the first reagent for this reaction, right? Which is, give me 1 second. The first reagent for this reaction, the mercury reagent with the OAC2, and it's in THF. And you're going to be subtracting H2O, and it's the fast mechanism. So what we get here, what we need to know, so in Markovnikov addition, this carbon has more hydrogens than this hydrogen. So this carbon, what's going to happen is that the mercury complex is going to act like a hydrogen, and it's going to go to the carbon that has more hydrogens, and the oxygen is going to act like not a hydrogen and go to the carbon that has less hydrogens. So we have, over here we have CH3, CH2, CH, the alcohol group attached to the carbon that has less H's. And then we have the CH2, and the mercury complex acted like a hydrogen, right, and attached to the carbon that had more hydrogens. So acts like hydrogen. Alright, so let me just like that. Alright, and then step 2 is demercuration. And that is CH3, CH2, CH. We have everything in place, right? It's the same molecule with the mercury complex right here. And we're going to treat it with, let me just make this little crazy arrow. We're going to treat it with NaBH4 and a hydroxyl anion. It says that this is the slow step. And what we're going to get is a replacement. We have CH3, CH2, CH2, CH. The OH stays on the C where it was, and then on the CH where this was CH2 with the mercury complex on it, the mercury complex got replaced with an H, so now it's just CH3 plus the mercury complex. So then you just need to know it's Markovnikov addition, that if you have something like that, when you make the complex, put the mercury complex on the carbon that has more hydrogens, treat it like a hydrogen, so that in the demercuration step, which is the second step, the alcohol is on the carbon that has less hydrogens, and when the mercury complex is replaced with an H, you get like a CH3. So now I'm going to do the actual problem.